All right. So 6.7 is really just about, I think, mainly word problems. So it starts off with, actually, yeah, it is word problems. Yeah, here we go. This is a little challenging. No, I think you do that one. Let's see here. This one, it's interesting. Let's see. Oh, we'll have one like that later. So there's a few questions on displacement on the exam. I'm not going to cover the displacement. It is interesting. Let's see here. So if you see anything about displacement on, skip it. Exam 2, I should say. It'll be extra credit, any displacement problems. I'll leave them here for you to go over on your own, but you don't have to do. But it is an interesting topic, so I'll leave it there. Okay. Mainly going to be problems that we started last time. Right. I would like you to look over the displacement and harmonic motion on your own, just because it's a cool concept. Again, you won't be tested on it on exam 2 or the final. Okay. Let's save before I forget. Okay. Yeah, let's do a few out of the homework since they're just live type stuff. So number 5. This is 6, 7. I'll switch over in just a moment. Applications and models. Number 5. Example 1, problem 5. So we don't need any real theory here because we've already talked about definitions of sine, cosine, tangent. So that's all we're going to need really. We're going to use those to help us find these angles and sides. So basically your job here is to find all the angles, all the sides. That's it. Okay, so keep it simple. The instructions will be solve the triangle. All right, and they're gonna give us A equal to 60 degrees. B is missing. Capital C is missing. So A, B, C capitals are gonna be the angles. Switch over just a second. Lowercase will be the sides. They gave us lowercase c. Okay. Got a picture real quick. You guys see the paper okay? I'm in a different place today, so I don't know if the lighting's okay. Just let me know so I can adjust. Now, technically, this is a right angle, right? So since it's a right angle, we actually have right triangle. We actually have 2 known angles. So they tend to label the right angle as C, and the other angle is A and B. Okay. So this is actually 90 degrees. this angle 60 degrees. Now, just to get into the habit, because when we get to chapter 8, I think, or 9, I don't remember. Pretty sure it's 8. The lowercase are going to go opposite to the capitals. So the B is right here, lowercase b is over here. Okay, just get into the habit of that now because it's going to be helpful. Lowercase a is the opposite. Lowercase c right there. So we got 12, right? Now, we should all know that the sum of all three angles is going to be 180 degrees for a triangle. So if we have two angles, then we can find capital B. So we should know that B is simply going to be 180 degrees minus the other two angles. What is B going to be? Uh, 20, right? No. Oops. 30. Okay. 180 minus 90 is 90 minus 60 is 30. Okay, so there's my 30. All right. Now, since it's a right triangle, we could use Pythagorean theorem once you have one more side. But we're going to find one more side. So this is when you have to use your sine, cosine, tangent to help you out. We have the hypotenuse, C, right? So which function would you use to find A or B? Sine, cosine, tangent, I mean, any of the six. Which one would you choose out of the six? You want to choose one that incorporates the hypotenuse. You also need to choose which angle you're going to use to your advantage. Okay. Doesn't matter which angle you choose, but remember how I said last time, if I choose 60, this becomes the new opposite side. If I choose 30, this is now the opposite. So you choose your angle. So first, let's say, and then you choose your function. So either sine or cosine will be fine because they both use the hypotenuse, right? Sine is opposite hypotenuse. Cosine is adjacent hypotenuse. Doesn't matter, either of those would work. The only one that doesn't work is the tangent because we have these sides missing, the legs. Okay. I'm gonna box the ones that we found. Okay, so this is what I'm thinking. I'm gonna choose sine of 60, just because. So now opposite is A over hypotenuse. Does that make sense? Solve for A. So multiply both sides by 12, we'll get to here, or cross multiply, however you want to think about it. Is everyone cool if I skip that step there? Is that clear? Just let me know. At this point, we need a scientific calculator. Well, actually, you could use your unit circle since it's a known angle. When we're doing applied problems, we might as well use our graphic calculator or scientific. 12 sine 60 MIN is sine M. Okay. So it looks like little a is 10.39. They said round to 2 decimal places, so 10.39. Any questions so far on what we're doing? Okay. So don't forget, if you have 2 angles, you technically have all 3. You can always do this. All right. Now you could continue this, repeat this step right here, but use the b, or use a different function that uses b, or you could do Pythagorean theorem and solve for b. But I don't really like Pythagorean theorem unless I have to. And we're learning something new, so let's solve for b this time. So we use this guy to solve for b. Now let's use, I don't know, use sine 30. The sine of 30 degrees. You see how that would be equal to b over hypotenuse, right? That makes sense how this works. So I'm choosing this myself. That's the part you're gonna have to figure out. Okay, which function do I use? Which angle do I use? And then you solve for whatever we need. So multiply both. This time I'll show the step. Multiply both sides by 12. So b is going to be approximately 12 sine 30, which is 6. So there is 6. So we solved the triangle. Any questions about what we did? Okay, cool. So not too bad so far, I hope. Let's see. Let's look at the homework. Maybe we can pick a harder one. Let's do at least one more. So that we did number 5. Okay. Check this one out. It only has sides. All of these have an angle and a side. So let's do this one. It looks different. Number 8. friend texted me saying that they're flat and need someone to change their tire. I'm like, dude, I'm making plans for him. Figure that out later. Example 2. Problem 8. So they gave us solve the triangle of the instructions. I like to set it up this way. Capital A, capital B, lowercase a, lowercase b. My C's look the same, so if you can write your C's better, cool. Or if you want to put a line on top of it, just to distinguish the two C's, feel free. They gave us a B of 12.7 and C of 51.18. Okay. Okay. Here's my triangle. We technically have the right angle, right? That's why right triangle problems are easier, because we're always given one of them, if not more. We have little b, which is the opposite, 12.7. Little c, hypotenuse, 51.18, right? Yeah, 1/8. I didn't write the, if you want to write that c equals this and b equals that, you can, but the way I remember it is opposite to b is b, opposite to c is little c, opposite to a is little a. So I know what these are, and it's right here too. I just feel like it's cluttered when I write it here. So if you want to write more, write that there, it's up to you. Okay, so I don't have any angles here or here. So we're gonna have to use inverse sine or inverse trig functions to find A or B. So again, this is the part that you need to think about. What function would you use to solve for, let's say, capital A? Yeah, we're gonna use cosine and then use cosine inverse, correct? Let's do that. So set it up. Cosine of capital A. So I'm choosing this myself. So this will now dictate, by definition, adjacent over hypotenuse. Right? Now, as Raymond said, we can do cosine inverse of both sides to solve for capital A. Does that make sense? These cancel, so capital A will be whatever this is. It's time to use calculator. So in degrees, these are all in degrees. They didn't say, well, let me look at the question. Yeah, honestly, if you look at the question, I think this is their screw up. check it out. They did not mention degrees or anything. I knew it was degrees because I saw the answers. So I think they should have told us. That's not cool of them, but it looks like all of them will be in degrees for solving triangle problems. So there might be an assumption being made here, which is fine, I guess. Anyway, we got what? 75 down to 2 decimal places, they said. Okay, there's A. So when you have 2 angles, we can find missing angle no problem, right? So B is equal to 180 minus the other 2 angles. So whatever they are, we'll have B. .37 degrees. Any questions so far? Either about anything, beginning, middle, end. But all we need is that missing side, right? Okay. I say let's use sine A, just because I can get opposite over hypotenuse. We can solve for opposite. Okay, so here we go. I'm gonna put little stars on the steps where we solved. For certain pieces here. So I'm choosing sine A, right? Which I know what A is now. Sine of 75.63. 14.37 equal to opposite, so I don't know what the opposite side is, so little a over the hypotenuse. Do the same thing we did over here. Well, actually, that was the last question. Just solve for a. So the algebra step, we'll skip that this time. A will be equal to 51.18 sine 75.63 degrees, which is approximately something. $49.58 is what I got. There we go. We solved all the sides and all the angles. So depending on what they give you, you have to decide how you're going to set this up. I think The math itself is not too crazy. It's just, can you reason your way and set up a problem the way you need it? Okay, so you need to remember definitions of all the 6 trig functions and visualize the right triangle. Okay, so just draw it out every time if you can. Any questions on example 2? Well, let's do some more problems. You guys cool on this page? I'm going to turn the page in a second. Okay. This is problem number 9. So put the problem in the chat box just because it's a lot to write. It says the sun is 25 degrees above the horizon. Okay. Find the length of a shadow cast by a building that is 100 feet tall. Okay. Let me see here. So this is what I'm picturing. I got some building here. It's 100 feet tall. Right. There we go. Got the sun over here somewhere. Casting a shadow. So the shadow I'm picturing is going to be a hypotenuse. Okay. All right. So the shadow, they want to know the length of the shadow. Well, actually, I think the shadow should be on the ground, right? Obviously, not the hypotenuse. So what else did they say? The sun is 25 degrees above the horizon. So 25 degrees. So if they say angle of elevation, that means you're going to be looking upward. But here they said the above the horizon. So for me, that means above the ground from sea horizon here. Yeah. They should have said elevation, but anyway. 25 degrees. They want to know this side. From here to here. So again, which trig function should we choose to solve this missing side? Yeah, for sure. We want to do tan 25 because we don't have a hypotenuse, so we got opposite over adjacent. Solve for the adjacent side. And we'll be good. Cross multiply or do whatever you want to do. Adjacent side will equal 100 feet over tan 25. 214 feet sounds reasonable for a shadow of a building. Any questions on the setup? Let's do one more and then we're moving on to something else. This is problem 11. Problem 9, they gave us a picture, but here they do not. So we got to draw it ourselves. Okay. A ladder that is 10 feet long leans against the side of a house. All right. So I'm picturing some house over here. The ladder is leaning, I don't know, something like that. Make it a little bigger, I guess. So here's my ladder. The ladder is 10 feet long, so that means that this side is 10 feet. Oops, sorry. Okay. The angle of elevation of the ladder. I'm understanding it's elevations like this or 85 degrees. Find the height from the top of the ladder to the ground. So they want to know this right here. Okay. Put that right here. They want to know this guy. All right, whatever. Okay, so they want to know opposite side. So what trig function would you choose? Now that we have the picture. Call it X, I guess. So if you have hypotenuse and you want to find opposite, you should probably use sine, right? Sine of 85 be opposite to this angle over the hypotenuse. Solve for x. X will equal 10 sine of 85 degrees in feet, which will be 10 sine 85, 9.96 feet. Sounds reasonable, right? If I'm on a 10-foot ladder, I expect to be above the ground, you know, somewhere around 10 feet. I wouldn't expect myself to be like 100 feet in the air, right? So always think about it. Like, does my answer make sense? And it seems fine. They round to 1 decimal place, so this actually becomes 10. Okay, any questions on 6.7? It's the end of chapter 6. Okay. Syllabus again.